Please welcome to the stage Axios senior energy reporter, Ben Geeman.
Hello, hello. Good afternoon, everybody. It's great to be here in Las Vegas at the Innovation Summit with everyone here. Thank you so much for joining Axios. I co-author the Axios Future of Energy newsletter. If you don't already subscribe, you can sign up at axios.com. And so, today we'll host conversations exploring technology, AI, and infrastructure innovation, and how they are shaping the next chapter of energy. Now let's get started. Sit tight for our first conversation, and I'll be back on stage in just a little while. Thank you.
Please welcome Axios Live host and moderator, Ryan Heath.
Hi, everyone. Are you ready to get out of your food comas? That's what we're going to do for you over the next hour. I want to start with a big thanks, of course, to Schneider Electric for making the program possible today and for inviting Axios to be here to add to this wonderful innovation summit. If one French connection here at the Fontainebleau wasn't enough, we're going to give you another one right now. It is my pleasure to welcome to the stage CEO of Schneider Electric, Olivier Blum. Come on up, Olivier.
Good afternoon.
Now, Olivier, you're leading a global energy technology company at a time when both digital and energy systems are just being revolutionized. How do you see that landscape evolving? And tell all of the folks here in this room, what do they need to be doing to stay competitive in that environment?
Well, look, first of all, I don't know if I can teach or tell to the people what they have to do. You know much better your job than I know. What I can tell you for us, Schneider Electric as a global company, you know, we've been in this electrification industry for very, very long. I've been working in the industry for more than 30 years right now. And the speed at which we see technology changing has nothing to do compared to what we have known in the past. So for us, Schneider Electric, the obsession is not only to be a tech company which is good at innovating, but at innovating fast. The cycle in which we are entering has nothing to do with the previous one. You know, I used to take example. We used to, for instance, develop a new generation of circuit breaker. You spend 2 years to think about it, you spend 3 years to develop it, you launch it, and that stays in the market for the next 10, 15 years, and that's it. Does not work in the world of tomorrow. This morning we talked a lot about electrification, digitalization. When you look at what it means for our industry, what are the type of product we need to develop? Every single product that we develop has to be software first, has to be connectable. Every controllers that we are developing has to be software designed. We need to extract data at every level. And of course, all of that is influenced by electronics. The speed at which electronics is changing is also going to impact quite a lot our industry. So to cut it short, if I would be in front of our Schneider Electric team internally, I would say speed is a new currency. We have to change the clock speed of our company and probably of our overall industry if we want to stay relevant in the next cycle.
And what about agility? We were speaking backstage about the complications of a more regional global economy, geopolitics today. How do you cope with those factors?
Well, look, it's very, very interesting because we have always this question, sometimes from analysts, from investors, what do you think about geopolitics? Is it going to get better next year? I don't think so, personally. You know, I spent the past 20 years, for instance, of my life between China, India, in those economies where it keeps changing every year. And now what we see at global scale is that geopolitics are there to stay. Probably we are entering in a new era in a world which will be a bit more fragmented, and that's not for me to comment and to say if it's good or bad. But for multinational, it means we have to change the operating model of the company. We've grown up in companies which were local and regional, and we have been told one day that the magic recipe is globalization. We have been advised, and I hope there is not too many consultants in the room, but we have been advised for a lot of money by a lot of consultants that the world was about globalization. And probably it was true at one point of time. We at Schneider, we have globalized our supply chain, we have globalized a lot of stuff. But while it brings a lot of value in a company, we believe at Schneider the future is about regionalization. It's about building a model where, well, you have a global strategy with a certain number of things which are extremely strategic that you want to maintain at global level. It can be about your capital allocation, about your key people, it can be about platforming in technology. We want to create a model which is much more regionalized. So what does it mean for us is from the customer to the salespeople, to the R&D, to supply chain, to our supplier, we want to create a regional loop to make sure we go much faster. You know, when you grow up in a company like Schneider, like I did, being a French guy, spend a lot of time in Asia, spend a lot of time in the US, no way you can understand every single region in the world. It's just moving and changing so fast. So the only recipe is to create those regional loops, which are much more agile, much more faster to stick to the local market and to make decisions. So that's what we believe, and that's a way to make the most of the geopolitics. I prefer to build a model which is much more agile. Complexity is great if you do better than the other. So that's what we are trying to do at Schneider Electric.
Got it. Now, thinking on the energy usage of AI obviously consumes a lot of energy. It is also one of the best paths to saving energy. We also have a situation where a lot of the companies involved in using that energy have been real leaders in clean energy. So what's your take on the benefits of a sort of well-run data center? How do you make sure that you're really delivering those benefits across that ecosystem?
Well, look, it's an excellent question, and we've been at Schneider Electric a very strong advocate that the future is about electrification and digitalization. Electrification has started. We see that the usage are starting to be more and more electrified in home. We see it also in transportation. We see it in industry, going at different speed in different parts of the world. What we see coming with AI is taking digitalization to the next level. What I'm just trying to explain is for us, we've made sure that all the new devices, all the new equipment we launch in the market are connectable by design. So which means that you can connect them and you can extract data. But we were probably still a little bit weak on the technology side. What do you do with those data? Now, once you have those data available and you're able to structure those data, and we are creating at Schneider Electric a unique data hub which combines energy and process data, then you bring efficiency to the next level. Imagine your home. You have an electrical panel in your home. I'm sure you have one. All of you have one. Today, this electrical panel is not intelligent. Imagine the time where your electrical panel will become smart, where you can extract data. But we don't want you to go on your mobile phone to change the temperature of your air conditioning or heating system. But the system will learn by itself, and thanks to AI, will manage your electrical installation and therefore your energy consumption by itself. You change the energy consumption in the world, in building or in residential. Guess what?
And not just homes, you do it in stadiums, you do it in hospitals.
And guess what? Building represents 40% of energy consumption in the world. So data center, or let's say AI, therefore, you know, there is no AI without compute, there is no compute without energy. So of course we have to provide those infrastructure, which at a first look like a huge increase of energy consumption, but that's what will bring energy intelligence. And that's where a company like Schneider wants to play a big role to create that convergence between the need for compute and the need for more efficient energy.
And thinking beyond homes or data centers, when we're really looking at that nexus between AI and energy, what are the technologies that you're most excited about?
Well, look, I'll give you a couple of examples. We have our team, for instance, in the US, they've developed this software which is called Resource Advisor, which helps for enterprise. We use it at Schneider to understand all your energy consumption. You can translate that in CO2 emission. And we used to have this software as a support for engineers to provide services to the customer. What we are doing now with our team, and I'm quite excited with what they have done in the US, they have brought AI in this software. They are creating agents where more and more we can sell a software to our customer, and we hand over to the customer, and by themselves they can leverage the platform, and they don't need us to come back every single day, and that creates sometimes some slowness in the process, and they can manage by themselves because they have the software which is intelligent, which has agent that can solve most of their problems. They don't need to call Schneider Electric, and we can come with our level 3 expert when they need really the level of expertise. So that's one of the examples. And you can scale it a lot
easier than some hardware as well.
The second example, which is very exciting, and if you have time to go to the marketplace, is what we call the EcoCare franchise. We sell low voltage panel, we sell medium voltage panel, we have our UPS. All those devices now are intelligent by design. They have the native connectivity. You extract the connectivity, and we can provide a digital service to our customer to anticipate, for instance, the obsolescence of the asset. So we don't need to sell a contract where you send engineer on site 4 times per year to check if the installation is still working, if it's still safe or whatever. We extract those data to help us to do preventive maintenance. So that gives tremendous value to our customer. So that's another example where hardware and digital combined create new value for the customers.
Now, you have a new report out which really outlines that there's 1,000 days to define America's energy future, where literally every day counts. What are the priorities that you're personally sort of trying to instill across the organization and that you think everyone here should be focused on?
Well, for us, our key message is everything is about energy technology, and the good news, those technologies are available today. It's not like we are talking about technology that will come in 3 years, in 4 years. I was talking about the new resource advisor, which is available for demonstration here. We are launching, for instance, EcoStruxure for sites, which help you to manage power and building management through the same platform. So my message is those technologies are available. We need to embrace those technology. And if we are all moving as an ecosystem, from the utilities to the supplier like Schneider to our different partner, our supplier as well, we can deliver the mission of this country, which is really to increase, to meet the energy demand, and to meet the energy demand, of course, which is required for all the AI technology that we need. So it's a very exciting moment. And I don't think it's a time where we should complain too much. I think we need to embrace this opportunity and see how we can transform our industry, because that can really take energy tech to the next level.
Yeah, I share your optimism. We've got time maybe for one last quick question. Technology is not just about the gadgetry, it's also a human story. What are the sort of workforce and skills strategies that leaders here in the room need to be thinking about to make sure they're at the front of this AI revolution?
Well, I'm glad that you asked the question, because in 3 weeks from now, we are going to disclose really the next sustainability commitment of Schneider for the next cycle, which come on top of everything that we do on the business. What else we can accelerate? And I can tell you, we'll see that one of the biggest commitments that we have is about the electric workforce. Because we know we cannot deliver and we cannot bring those energy technology to our customer if we don't need the number of people who understand electricity, electrician, but people who understand the basics of electricity, but that can understand also our digital, because it's not exactly the same technology, this is not exactly the same competencies. So we are committing at the company to help in every ecosystem we work in the world to increase the number of electricians and to make sure we bring the digital layer in terms of competencies. And of course, I would encourage all the people in the room to contribute, because those technologies we are talking about will never happen if we don't create the workforce that we need to install those technologies everywhere in the world, and especially in the US.
There we go, some good AI jobs news. Olivier Blum, thank you very much.
Thank you very much. Thank you. Thank you.
Welcoming back to the stage, Ben Geeman.
Hello again, everyone. I will be up here on stage for the next and final 2 conversations of this program. Next up, we'll hear from a leader who has helped redesign the modern data center, and with it, the way that energy and infrastructure intersect. Please welcome to the stage Rob Roy, the founder and CEO of Switch, a company with a very important footprint in this state. Thanks for being with us.
No, thanks for having me, Ben.
Yeah, this is great timing. Let's jump right in. Just today, NVIDIA and Microsoft announced that they are investing a cool $15 billion in Anthropic. And honestly, we're seeing a lot of these kinds of moves. So I got to ask, is this a bubble?
You're going to ask that to everybody that comes up? Is everybody today going to ask me if it's a bubble? Yeah. And I'll jump in maybe and explain that, because we have this timing. I'll go a little fast. I started Switch in 2000, just in time for the dot-com time frame to auger straight into the ground. We went through 2008. If you look at how those bubbles came about, though, there were things like Broadwing building a $1.7 billion network through the western United States without a single client. The concept was to go in all these small towns and give people $40 internet. They never even did any of that. It went bankrupt before it even opened. We have it in our gateway here because of the Enron building. and it sold for $131 million when they had just invested $1.7 billion in it, because there were no clients.
Yeah.
The difference today, of course, with AI is the clients are the largest companies in really human history, multi-trillion-dollar companies that have cloud revenue or advertising revenue, and they're putting a large amount of money into it. But I don't think it's a bubble. We had a robotics event here in Vegas last week, and we had a bunch of people coming in, and everybody's talking about agentic AI from a large language model standpoint. But they were a group that are building the brains that will go into robots, the brains that'll go into robo-taxis. And if you look at kind of the difference from a training standpoint, LLMs have done 100 trillion parameters of training. If you look at LLMs and open world and different things. Multimodal for robots, if I build a brain that's got to go in that robot that's going to walk over there and deliver a drink, they've only done 1 million parameters.
Oh, wow. So just scratching the surface.
1 million against 100 trillion.
Yeah.
And so the amount of work that we have to do on the robotics side in terms of how many GPUs are going to be needed for that, literally, we've got to do 100 trillion parameters of how multimodal, how a robot actually, and they can't learn it from language, they've got to go learn it visually from a whole different way of training. I need to see that, and I need to know exactly how much pressure to put on that glass to pick it up. So I think we're a long ways away from a bubble. There could be a couple of things that bubble out, and one of them I think that's a little dangerous is behind the meter power with no pathway to being connected to the grid. Those are interesting 8 years out. We don't do that, and most of the big clouds don't do that. Everybody's still being very careful with that. But if there was a bubble, maybe that, but otherwise I think the GPUs are going to be needed for a long time.
Definitely. Thank you. One of the narratives that is out there is that the growth of data centers is a significant reason, certainly not the only, but one of the reasons that consumer electric power bills are rising. I mean, just last week in elections, or 2 weeks ago now, in the elections in Virginia and New Jersey, power bills were a big deal in those races. Same with the Georgia Utility Commission. Is there a backlash brewing?
Well, I think there is from maybe a couple of bad choices, not necessarily bad actors, but some things that some of the big companies did over the last 10, 15 years. Overseas, some stuff. Company shows up, there's a dam, it's 100 years old. They make a deal to get 3-cent power off the dam. And then, of course, now there's new residential things coming online 3 years later, and obviously it's a little hard to build another 100-year-old dam. And so we, the people in that country, had to eat the costs on that, and that kind of made the industry look bad. But I'll give a perfect example here in Nevada. We're currently, on a path to consume 1/3 of the power in Nevada, just switch, and really with
Sorry,
growth.
can you repeat that, please,
Yeah.
for everybody?
Yeah, 1/3 of the power in Nevada actually is, the run rate that Switch has. We're the largest client for NV Energy, and power rates for Nevada residents went down last year. And so this can be done really well. I think that the two big mistakes on that are, that people don't understand. Like, hey, are data centers good partners for the grid? Well, let's say I'm running a gigawatt of electricity. We run that 24 hours a day. It doesn't change. So at night, when everybody in the houses, all the businesses shut down, and they're not paying a power bill anymore, or a much lower one, the power plants run all night long. All those electrons eventually are wasted or only partially used. Nobody's helping pay for the grid at night, but the data centers come in and you go, well, no, I mean, in the winter, the whole state can run 3 gigawatts. So if we're running a gigawatt all night long, we're uniquely paying into the grid to support it and expand it and grow new things. And so that's one that gets missed a lot by all the kind of false narratives that are coming out in these states or these kind of hit pieces. Nobody really sits down and analyzes that. Done well, it's a great partner for the grid. The only way it's not a great partner for a grid is brownouts. And so let's say your state peaks at 6 to 8 gigawatts. You have maybe 12 times a year, if it's a hot year, where you're going to clip, the peaking ability of that state to the point where they're going, oh, we're going to have to brown out power somewhere. Of course, in the last 5 years, it's really changed on our side about going, well, no, just call us, because I'm running 1/3 of the power in the state. I'll just put X amount of buildings on generator for 3 hours, 12 times a year, and it won't affect you in any way. It'll never brown out, because we could lower 500 megawatts if we wanted to.
So that flexibility is there.
It's absolutely there. It used to be harder to do because the clients wouldn't accept that, but that's all changed. Like, the clouds really understand their responsibility and what they need to do to help, and to just easily go on generator for Sometimes it's 12 times a year, but it's like 19 minutes is all that was going to brown out. That's one of the outages. And so it's very easy to make data centers a partner with every community in terms of the grid.
So what you've just walked me through sort of runs against what we're hearing sort of in the press from certain politicians. This narrative, is out there, certainly. Does your sector or does the industry in general need to do a better job communicating that message to the public and to policymakers?
This is going to be a quick question. Yes. Yes, we do. Yeah, the fact that most of the world doesn't even know what I just explained. So I think after the new year, even just Switch itself, we're going to be spending quite a bit of time in Washington, quite a bit of time with our other states, letting people know.
As you talk to other colleagues in this space, other companies, is that something that you expect to see from others as well, a sort of effort to kind of perhaps better educate Washington and perhaps state capitals as well?
Yes, and the clouds. All 6 of the primary clouds understand that too. We have a group that I think will be getting together after the new year and really working on this problem.
I want to talk about nuclear in the midterm and the long term, and perhaps the very long term. So you're working with Oklo and other small modular reactor startups. Ultimately, looking out some number of years, are these types of units nice to have for AI growth, or will they ultimately be a must-have for AI growth?
And so they're a must-have, and I think it's the most interesting part of really what AI is going to give to humanity, and because we're a power company as much as we're a data center company. And AI is going to do all these amazing things, but because of the growth it's having, it's the only thing in the world that has really trillion-dollar expenses coming due, being paid by trillion-dollar companies that can actually pay the bill. And we are going to see really, a revolution in energy that comes from the fact that AI needs this power. America's short a terawatt of electricity without AI or data centers. We actually own Terawatt America, and so that we have to build a terawatt of energy just to grow America correctly over the next 20 years. Then you add in AI and data centers, 80 gigawatts, 200 gigawatts, depending on what part of it you're talking about. But because of that, we are going to create, new clean fission is going to become a really viable energy source. And SMRs, but even just, all the new 1 gigawatt nuclear plants, the primaries, those are all starting to kick in now. I probably could name 30 projects that are underway in the United States.
So you see the U.S. will start building gigawatt scale AP1000s or some other design?
And literally was looking at a design yesterday for 4 AP1000s. And so that's going to happen. I think the other thing that's going to happen about what AI really changes the world is that it's going to speed up fusion by really 2 or 3 decades. And that kind of, fusion changes all the things. And we've been, I started here in Nevada back 26 years ago. Our first client was the test site, Area 51. So I really understand nuclear, been doing that, from a clearance standpoint and everything my whole career. If you see what's going on kind of behind the scenes, the stuff that happened during COVID, there's some really great things that step forward. I thought it was maybe still 30, 40 years away, 2 years ago, with AI speeding it up. And that, the interesting part with fusion is it changes something for the world. I'm talking about humanity. AI is going to do all these great things. But the number one source of poverty globally is energy poverty. If you could get to the point where energy is free, you can solve all food issues. You can solve all water issues. The ocean's big. It's 56% of the cost of desalination is energy. And so, I think we're on a really exciting path with not only AI going off and doing all the things it's going to do, but because of that, it's creating a whole new, power renaissance in the United States where new clean fission, and, Oklo especially, some of those things, NuScale, all our partners, really an exciting time for that. And I hope everybody understands that. We have to embrace nuclear. Otherwise, AI is just going to burn a lot of fossil fuel, and we don't want to do that.
Yeah, definitely. Speaking of, I suppose my kind of hottest and most sophisticated take is that nobody really knows the future. And that was a joke. So when we were chatting the other day, you talked about the need to sort of future-proof your operations and your infrastructure for your clients. Can you tell us a little bit more about what that means? Because certainly there's just uncertainty piled upon uncertainty. One kind of hobby of mine is looking at demand growth estimates related to AI, but also all the many things that are even driving demand growth more. The uncertainty bands are so gigantic, as you know 10 times better than me. So what did you mean when you said you need to future-proof your operations for your clients?
Well, and so the other thing that could be a bit of a bubble is, there's a race for AGI, and we know all the gentlemen that are involved with that. you've got 10, 15 people on Earth really wanting their name to be in the history book as I created AGI. So they're going very quick. In my opinion, they're going too quick with, really maybe $100 billion of data centers that are just kind of crypto shed 2.0 designs. It's a warehouse with a pipe in it, and they're going, well, we can liquid cool this stuff. The problem is if you look at the roadmap from NVIDIA, and if you look at Oberon, and then you jump all the way through, guys, to Kyber, Feynman, we're on a path right now to where, like, the stuff that we're currently building out in all the AI factories are 157 kW a rack. In just a year from NVIDIA, but also ARM. Renee's in town, and he's a Raiders fan, so everybody was over at the Raiders game last night. But guys, so ARM has a new design coming out by June, July of next year that's 500 kW a rack. The high side of Oberon is 365 kW a rack, but jump forward to the final three steps, it's 1.2, 1.5, 1.7 megawatts per rack, already on the design table now. And so, like, these buildings that are being built can't really even go to that second generation that I talked about back on just the step to 300. And so it's a lot of, you kind of were out you'd seen the stuff we were working on, but with EVO now, EVO does 2 megawatts a rack now. And I started working on that 2 years ago, and part of that is because of our relationship with ARM and NVIDIA and Qualcomm and Broadcom and Marvell, they're all clients of ours. And so the building's designed seismically to hold 5 fluidic systems that are just gigantic. If you really look at how big this stuff needs to be to do 2 megawatts in every single rack. And then air, we can do now 180 kW of air in every single rack, and also that's design system plus system. These aren't just N crypto sheds. These are data centers that not only do AI better than AI and then grow through every one of those evolutions, is you could actually go back in time 5 years from now and just turn it into 180 kW air-driven data center for every rack, which there aren't any of those that exist anywhere else in the world anyway right now. So very modular, very fungible with those different things. And that's kind of the future-proofing side. You could be wrong just one generation in and not have a pathway, not have the seismic, not have the strength, the support. I've got to run another 24-inch line through this building to try to get to this new set of gear. The other one, too, is a lot of the cabinet design concepts that you see aren't really taking into effect what's happening with, say, Meta or Microsoft or ARM's 48-inch wide racks that come from the factory pre-populated, 48 inches wide, 5 feet deep. They'll have 2 sidecars on them at a future date, one for power, one for network. And so the stuff's just going to be much bigger than people are thinking right now. And designed wrong or poorly or too quickly right now really leaves this still a $3 billion data center not very usable in just a not very too short time frame in the future.
Thank you. As our time here runs down, I wanted to end with just a quick lightning round question. What is the biggest myth in this space that needs busting?
The biggest myth, how's this? It's kW per rack. I don't want to say that everybody other than us is lying, but they're all lying. All right.
I think that's a great note to end on. Thank you, Rob. Thanks for joining Axios today. Really enjoyed
thank you so much. Good to see you. Thanks for coming.
All right. For our final conversation, we're going to have a perspective from smack dab in the center of one of the most complex and important and closely watched power grids in the United States. Our next guest has spent over 30 years in the energy business and 10 years in the United States House of Representatives. Please join me in welcoming former Texas Member of Congress and current ERCOT Board of Directors Chair, Bill Flores. Hey, Bill.
See ya.
Good to see you. So, lots of news I want to get your perspective on, and lots of ERCOT relevant news. Just to set the stage, in the last few days alone, Google has announced plans to invest $40 billion in Texas.
I was there.
Yep.
Yeah.
And then the respected analysis firm, Grid Strategies, in a report over just the last day or so, now sees 53 gigawatts of load growth coming in Texas. And this is not in the distant future. This is by 2030. So, data centers
It's actually more than that, but
is that an underestimate?
Keep going.
Wow. So, data centers are among many drivers, as we've been discussing in other conversations. How can ERCOT handle this? without sacrificing reliability? And what can ERCOT teach other regions of the country for which, what you're seeing is eventually going to arrive as well?
Okay, thank you. Well, it's great to be here. Thanks for Axios for inviting me. Let me open up with a couple of editorial comments if I can first. AI, I'm going to speak parochially as an American and as a Texan. AI is a race that we have to win. We have to be, this needs to be our moonshot for this generation. And the other thing I'd say is that you heard Olivier talk about there is no AI without compute, without energy. I would say it another way, and that is energy and compute are inseparable drivers of value when it comes to AI and the next generation. And so to answer your question, how is ERCOT going to handle this? Basically, it's going to take everybody working together, a collaborative approach. The interconnect queue in Texas last year about this time was about 56 gigawatts of large loads. Today, it's over 200. So think about that. It's had that much growth. Between now and 2030, Texas expects to add 62% to its grid. That's like adding California to Texas. So think about that. So the way to deal with that is the data centers that want to come to Texas, and it seems like about half the infrastructure development in the AI sector is going to Texas, is to come in and be flexible. And my admonitions to people that want to come to Texas are come in with the concept of being a good grid citizen. Okay, and that means come up with ways to do the peak shaving like Rob talked about earlier. So if you can peak shave over those 12 to 18 times a year, that is a net contributor to the reliability of the grid. Those are the things to think about in terms of doing that. And in the interim, given the interconnect queue, you're going to have to bring your own power. Be a net add. Like when I was at Google's announcement last Friday with the governor and with Google CEO, he said, we expect to add more power than we're going to consume. And so I think that's sort of those are the admonitions, or the way that people in this space needs to think about moving forward for the reliability of the grid, and also to control prices or cost to the consumer, as you heard Rob talk about a few minutes ago.
Are you sensing an increased willingness among the large data center operators and the hyperscalers to be willing to accept some of that power shaving and some of that flexibility? Because this has been a little bit controversial. I mean, everybody supports it in theory, but it's a real devil in the details kind of thing.
Well, let me say this. 2 years ago, if we were having this conversation, the things that people looked about for location were, find me a good substation with good transmission access, give me a fiber pipe, give me access to water, some sort of cooling media, labor, and cooperation with local government. Today, it's all those things plus speed to power. And given the interconnect queues that you have all over the country, this isn't just unique to Texas, people are looking at that differently. So the hyperscalers that want to be successful are looking at those. Because really when you think about it, if you're going to invest $40 billion in a data center, about 20% of that is power, 80% is chips and infrastructure. So the 20%, you don't want to let the 20% wag the tail that wags the dog. You want to bring your own power so that you can make that work. You're going to have the backup power anyway. You're going to make an investment in backup power. Might as well add whatever it takes for the reliability that you need to make it your temporary power until you can connect to the grid and make sure you've got a diversity of resources for 5 nines reliability.
I want to ask about something else that's kind of ripped from the headlines. There's a kind of a potentially really big federal policy change brewing. Energy Secretary Chris Wright has asked the Federal Energy Regulatory Commission to assume jurisdiction over the interconnection of large data centers and other large loads. A, is this a good idea? And B, will it happen?
Well, it's not going to happen in Texas because we're outside of FERC, fortunately.
But elsewhere.
But yes, I mean, speaking from a macro perspective, there needs to be a change. Yeah, there's going to have to, I mean, even in Texas, if you think about the growth of the interconnect queue, we've got to look at new ways of managing that. The same thing needs to happen nationwide. So there's got to be a new paradigm in the way you look at the interconnect queue and the way that you add load to the grid.
Do you sense, I mean, you're very familiar with Washington. I mean, already we're seeing state power regulators kind of pushing back against this. We're seeing some utilities being, very hesitant about this.
Yeah.
From a sort of political standpoint, I suppose, is this something that you see political will to accomplish over that resistance?
Let me say this. I think that you had pushback when the interstate highway system was built from local governments, from states, and so forth. If we really want to build the AI future that we think we need, I think everybody needs to get on board, and that would include state and local politicians as well as federal politicians all working together. Or policymakers, I don't like to call them politicians, but policymakers need to work together.
Definitely. I mean, part of this actually that's contemplated in Chris Wright's rulemaking proposal.
Yeah.
I mean, it was written in very kind of broad
Chris is a
strokes,
smart guy, and I think he's leaning in on this, and I hope that he will be successful in convincing all of the stakeholders that we all need to pull together to make this work.
And one of the things envisioned in that is kind of co-location of data centers and power sources.
Right.
How should grid regulators deal with this? I mean, just yet another thing ripped from the headlines. Just last week, Chevron said that it identified the location for its first behind-the-meter gas plant that it's going to be building for data center campuses, and that is going to be in West Texas. Behind-the-meter gas plants or other big sources, good idea? And
Absolutely.
Okay.
Yeah, I totally agree. And look, I mean, people say Chevron hadn't done this before. Chevron and several large energy producers have behind-the-meter power plants in order to power their refinery operations, their chemical operations, and so forth. So this is nothing new. It's just a matter of the scale at which they have to do it. So I applaud those types of decisions. Look, there's a lot of gas in the Permian that's sort of locked because of pipeline capacity that can't get to the Gulf Coast, and so a higher and better value for that gas, rather than being trapped in the Permian, is to use it to produce electrons, to produce AI.
Certainly at the same time, we have a number, we're seeing a lot of final investment decisions this year for LNG export facilities in the Gulf Coast. Is there enough gas to go around in the region?
Absolutely, yeah.
Switching from gas to nuclear, there's a lot of interest right now and a lot of, but very, I suppose, MOUE, if that's a word,
Yeah.
non-binding memorandum of understanding, aspirational deals for these small modular reactors. So I kind of have the same question for you that I had for Rob. Are these ultimately, given the expansive growth of compute needs and power needs, are small modular reactors going to be a nice to have in this space, or ultimately are they going to be a need to have?
I totally agree with Rob. I think they're going to be a need to have. I mean, look, not everybody's going to need AP1000 in their backyard. I mean, I'd like to have a little 50 kW modular one in my backyard. I'd bury that sucker and leave it for 50 years. But we do need small modular reactors, and I agree with what Rob said, and that is that the hyperscalers, the investors that are putting capital behind AI are accelerating, bringing that to being where that they're energized, and I think that's good for the country. It's good for the environment. I'm very positive about it. Now we also need to speed up on the traditional giga scale nuclear, the AP1000s and so forth. We need to accelerate the development of those in this country.
Do you think we're ultimately, there was that, when the president was in Japan, there was that announcement made of an $80 billion agreement with Westinghouse and Kumiko and Brookfield, the co-owners of Westinghouse, that envisions a federal stake in some of these nuclear projects. Do you see, the quote-unquote nuclear renaissance, when I first started covering energy, was supposedly in full swing. We have not yet quite seen the renaissance. Yeah. Do you see more gigawatt-scale reactors coming online as well? I mean, it's hard to know whether Vogtle was a cautionary tale or a great learning exercise that can be replicated.
Well, you had Vogtle, and I've been to Vogtle 3 and 4. On one hand, that was a cautionary tale, but then you also have what happened in the UAE, where they built each one of them sequentially, and the cost went down, the learning curve went up, and the time to completion went down as they went. And look, as a capitalist, I'm not a big believer in industrial policy, except where it really makes a difference. And if you think about why we don't have, more AP1000s today, is because the NRC screwed up the process of licensing years ago. And if we just stayed firm and continued driving forward, would do it. So in this case, when it comes to nuclear, I think we need to have a national policy, industrial policy. Is we're going to have nuclear, we're going to have this date, we're going to adopt these sort of standards and move forward.
Do you think that need for industrial policy, certainly you've made the case for why it's necessary with large gigawatt scale, AP1000 or other design. Is that also needed for the SMRs, or is that more of a private sector thing?
This is my editorial comment, so you can't attribute this to anybody with whom I'm affiliated. Yes, I think so. I believe that the NRC, Department of Energy, ought to say, okay, these are our 5 designs that we're going to move forward with, and put the pedal to the metal in terms of making sure the capital gets deployed, the licensing gets approved, and start the process of observing how they behave in real world time.
So Texas obviously is also home to the, now the largest amount of wind power, solar.
And solar and batteries.
And solar, yeah, solar's going gangbusters, batteries are going gangbusters. What is the nexus between the kind of combination of those intermittent sources and the growth of batteries? Do you see that playing a significant role in the kind of corresponding growth of data centers in the state?
Yes, I do. I think that wind and solar without batteries really are a challenge for a grid. And so, but when you add batteries, it can add that basically take intermittent renewable power and make it dispatchable. It really is a net positive to the grid. Look, we have an eclipse every night in Texas. and in the old days, the folks in the control room, once they got past that August peak at 5 or 6 o'clock at night, they could sort of breathe easy. Now, when you have your eclipse at night and you've got 24 gigawatts of solar dropping offline and you have to make it up, it's nice to have 20 gigawatts of batteries out there to get you to that hour ending 2200.
Definitely. Our time is winding down, so I wanted to kind of, yeah, that goes fast, but I wanted to do a lightning round with you as well. And actually, honestly, I have the same question because there's a lot of kind of storylines taking hold in this space. As someone with such a front row seat on the regulatory side, but also someone who has been in the business world as well, can you tell me about any sort of myths about data centers and AI and infrastructure that should be busted?
Well, let me say this. I don't think Senator Bernie has it right when he says they're raising cost. If you look at what Rob said, a data center can be a great stabilizer to the grid. We had a huge influx of crypto, let's say going back 10 years in Texas, and people were anti-crypto because they thought they were not good grid citizens. I was thinking about them as a giant shock absorber. When energy prices went high, they dropped offline, which corresponds with your peak loads, and so they can be a net buffer. Same thing with data centers. They're capable of doing it, and they need to be more upfront with that when they're applying for their interconnections.
Is that a sort of disclosure problem on their part or messaging problem?
I think it's been a mindset change. That they said, they're in the old days, like I said 2 years ago, they could come and connect the grid and turn on and not worry about things. And today they need to be much more adaptable and conscious of the way the public could perceive them negatively.
Congressman, thank you so much for your time. I really appreciate it. And thank you all for spending your afternoon with Axios here in Las Vegas at the Schneider Electric Innovation Summit. Hope to see you all at the next Axios event. And please do visit axios.com/events to see where we are all going to be headed next. Thank you again. Thanks, Bill.
You enjoyed that.
Yeah.
Thank you.